So we are going to continue working on some concepts in our packet. So make sure that you have your periodic table. You can either have your loose one, or remember on the back of your packet you have one. Okay, we just talked about the fact of how to find molar mass. So remember, molar mass is always the mass from your periodic table. Okay, so on your periodic table, right here, that's your mass. And we're always going to round to the hundredths place. So for example, on boron, it's 10.81. And notice that there's a 1 in the thousandths place. So we're just doing standard rounding. If in your thousandths place it's a 5 or above, you're going to round that hundredth number up. If it's below 5, you're just going to keep it. So here we're just going to keep this as 10.81. That's how many grams we have in 1 mole of boron. Okay, if we look at something like scandium, the mass there is, if I can erase that, is 44.95 grams. So on this one, we would say 44.9. We look at that 6. That 6 is above the 5 or above. So we're going to go ahead and take that 9.95 and make it a 0.96 grams. So in 1 mole of scandium, we have 44.96 grams. Okay. So that's what we just did on the bottom of page 1. Make sure you have that. And let's go ahead and look at page 2. We're going to fill in these 3 questions. Okay. Let's say that you love puppies. Oh my gosh, they're so cute. Okay. And you obtain 12 equally cute, identical puppies. Without weighing each individual puppy, how would you find the total mass of the group? Okay, so think about this. How would you find the mass if you've got identical puppies? Okay, if you said that we're going to multiply, you're 100% correct. We would take the mass of one puppy and then multiply it by 12. Okay, let's say that you love calcium, and calcium's super cool, okay? And you obtain 12 moles of calcium. How would you predict the mass of this amount without weighing the whole thing? Well, think about what you just did with the puppies. You would do the exact same thing. You're going to multiply, okay? If we have 12 moles, we know that 1 mole is going to equal the mass on the periodic table, and there's the mass of your calcium on the periodic table. So because we know that, we can go ahead and multiply, which is what we're going to do to solve these next problems. So let's go ahead and look at this problem right here. What is the mass in grams of 3.5 moles of copper? So what we're going to do is always start with what we're given. So here we're given this 3.5 moles of copper. So I'm going to go ahead and I'm going to write this down. And it's very important to always put your unit. For moles, you can abbreviate it as MOL. Takes off a couple letters. Okay, and I'm going to do what's called the fence method. I'm just drawing this line. And what we want to do, our objective here is to go from moles to find the mass in grams. Okay, so what we're going to do here is we're going to use a conversion factor. We know from yesterday that 1 mole of any pure substance, so here we have copper, is equal to the mass. And the mass, when you look on the periodic table of copper, is 63.55. We just barely did these on page 1, this mass. Okay, so this is a conversion factor right here. It's just like saying we have 12 inches in 1 foot, or 1 mile is equal to 5,360 feet, I think. I could have that wrong. Okay, so anyway, that's how much the mass of 1 mole is. So all we're going to do here is put this in our fence. So we want to cancel out our moles. So whatever we have here on this upper left-hand corner, we want here on the lower right-hand corner, because we're going to cancel out this unit. Remember that when we divide, we can cancel units out. So how many moles? 1. This is from our lovely little conversion down here. And that equals the 63.55 grams of the copper. We're going to put that up above because these two equal each other. Okay, so now what happens is that anything above this line right here, we multiply, anything below this line, we divide. So we're going to do 3.5 times 63.55 grams. Okay, it's like the puppies. If the puppies each, if we have 3.5 puppies, that's kind of gross and morbid, but 3.5, and they each weighed or had a mass of 63.55, you just multiply. Okay, you're going to want to multiply that, and when we do that, we get 222.43 grams of copper. That's the mass of 3.5 moles of copper. Now notice here on your problem, since we have moles of copper on this upper left-hand side, we have moles of copper on the bottom right side. Because we're dividing, this unit cancels and we're left with grams of copper, which is what the question's asking for. So all we're doing here is multiplying by the mass. Okay, let's do another problem. So this one says, what is the mass in grams of 2.25 moles of iron? Okay, so on this one, here's what we're starting with. We're trying to find, again, the mass of our iron. So we're going to do the exact same thing. We're going to go ahead and do 2.25 moles of iron. We're going to set up our little fence. Okay, and now we know, again, from what we learned earlier, that 1 mole of iron is equal to the mass of iron, and the mass of iron is 55.85 grams. Again, where do we get this? We get that from the periodic table. So right here, if I have moles here, I want moles diagonal. Okay, right there. How many moles according to our conversion 1? And that is equal to our 55.85 grams of iron. Okay, so again, once again on this, we multiply anything on the top, we divide anything on the bottom. Okay, so above this line we multiply, below the same line we divide. So here it's just 2.25 times our 55.85, and when we do that, we get 125.66 grams of iron. Okay, and that's how many grams we would have in this 2.25 moles of iron. Okay, pretty fun, right? I hope so. Okay, so let's do another scenario with these puppies. Oh my gosh, you guys, I can't even handle these puppies. Okay, they're so cute. Okay, you still love puppies. This time someone gives you a bucket of identical puppies. Can you imagine? Oh my gosh. They tell you the mass of the whole group. How would you predict the mass of each individual puppy? Okay, so think about this. How would you predict the mass of each individual puppy if you were given the mass of the whole group, the whole bucket? Okay, if you came up with division, you are correct. You would divide. You would divide that whole entire mass by however many puppies you had. So in this bucket, we've got 1, 2, 3, 4, 5. Uh-oh, did I just miscount? 1, 2, 3, 4, 5, 6, 7, 8 puppies. Okay, in this bucket, you'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 by 10. So you divide this bucket by 10 and this bucket by 8. Okay, so we're going to do the same thing, but with a pure substance. So here, it says how many moles of calcium are in 5 grams of calcium. So on this one, we're going to start with what we know, which is 5 grams of calcium. Make our little fence, bloop. Okay, and this is how many moles of calcium are there. Okay, so notice we're using the same units. We've got grams, which is our mass unit, and we've got mole. And mole just represents an amount of a substance. So we can do our conversion factor. If we go back to, again, what we've done earlier, 1 mole of calcium is going to equal the mass on the periodic table, which for calcium is 40.8 grams of calcium. Okay, so now notice we have grams up here. So we want to get rid of grams, so we're going to go ahead and put that on the bottom right, grams of calcium. And we know from down here from our conversion that that equals 40.08 grams. And that is equal to 1 mole of calcium, which is going to go on the top. Okay, whatever we put right here on the top and bottom of this line, they have to equal each other when we're doing a conversion. That's why we can put those on the top and bottom. Okay, and now all we're going to do is just the math. Okay, remember again, anything above this line we multiply, anything below the same line we divide. So here we're doing 5 grams. So 5 times 1 divided by this 40.08. Okay, it's kind of redundant. We really don't need to times by 1 because that would be the same number. So if you don't want to do that, you don't have to. You can just say 5 divided by the 40.08, which is going to be 0.12 moles of calcium. All right. Okay, so now one more thing I want to talk about is find the molar mass of CO2. CO2 is carbon dioxide. How do we do that? Okay, so far we've only done the mass of one element. Now you're telling me that we have 2 different elements, and not even that, but we've got 1 carbon and 2 oxygen. Okay, so we've got 1 carbon and we've got these 2 oxygen. So how do we find out the mass? That's how many atoms we have. Okay, so once again, we're going to look at our periodic table. Okay, so here's how you calculate the molar mass for compounds. You find the number of atoms of each element. So in that last one, we had 1 carbon and 2 oxygens. Then we go to our periodic table and we find the mass for each element. So again, you're going to the PT, the periodic table, and then you multiply the number of atoms by the molar mass for each element. And then all you do is, voila, add it all up and you're done. Okay, so let's do some examples here. So what is the molar mass of H2O, which is water? Okay, so here's what we're doing. We're saying, oh, we have hydrogen. There's 2 atoms. Okay, each one has a mass of 1.01. We have 1 oxygen atom. That mass is 16. So down here you can see what I've done in the formula. We have 1.01 times 2. That's our hydrogen. Plus the 16 times 1. This is our oxygen. And together it's going to equal 18.02 grams. So 1 mole of water is equal to 18.02 grams of water. Okay, let's do another one. Okay, right now we're on number 6 on page 2. What is the molar mass of H2SO4? This is called sulfuric acid. So here we have this outlined. Okay, we've got 2 atoms of hydrogen. There they are right there, and we multiplied 2 by its mass. We have 1 atom of sulfur right there, and we multiply that by its mass, 32.1. You can do 32.08, or that one, that's fine. And then we have 4 atoms of oxygen. Each one of these has a mass of 16. So here's all their totals, and all we're doing here is just adding all of these up right here. And so we know that 1 mole of this H2SO4 is equal to 98.12 grams. Okay, so this 98.12 grams, we say that that equals grams per mole, which means 1 mole, or you can just say 98.112 grams equals 1 mole. And this is, of course, of our H2SO4, which is sulfuric acid. Okay, how do you feel about that? Sounds good? I hope so. Okay, let's do this other one. Okay, this other one has parentheses. Oh my goodness, don't worry. It's just parentheses, okay? So let's look really fast. How many atoms do we have of each before I move on? Okay, so how many of calcium? We've got 3. Remember, with parentheses, we distribute. So there's 2 phosphoruses, okay? And then the oxygen, we've got 4 times 2, which is 8. Okay, so let's go ahead and look and multiply all those by their masses. Okay, so here's what we're seeing here. Okay, we've got 3 calcium atoms. Each one has a mass of 40.01, which equals 120. We've got 2 phosphoruses. Each one of those is 31 grams. That equals 62. And then we've got 8 oxygen atoms. Each one of those has a mass of 16, and multiplied, that's 128. So again, we're going to add these 3 masses together. When we do that, we get 310.3. Okay, So remember, that equals 310.3 grams.